Welcome back. In the previous video, we explored what Python is, some of its cool features, and why it's such a great language to learn. But now, my friends, it's time to roll up our sleeves and actually start programming in Python. Before we write any real code, there's one important thing we need to understand first, and that's tokens. In Python, a token is the smallest unit of a program that the Python interpreter can understand. Think of it like an alphabet of the Python language. Every time you write a Python program, you're basically combining different tokens to create meaningful instructions. Now, there are five main types of tokens in Python, and we are going to explore each one in detail. Starting with keywords. These are the reserved words that have special meaning in Python, like if, else, or while, etc. Then we have identifiers. These are the names you give to things like variables, functions, or classes, basically anything to which you can give a name. Then we have literals. These are fixed values like numbers, strings, or true and false, anything you don't expect to change. Then are the operators. Operators are the symbols that perform operations like addition and subtraction or double equal to for comparison. And finally, we have punctuators, also called delimiters. These are symbols like parenthesis or colon or comma and so on. They help with the structure your code properly. Together, these tokens are the foundation of every Python program, and in the next few videos, we'll take a close look at each type. Now, what are Python keywords? Now, this is another important concept that we will learn. Keywords are reserved words. Each keyword in Python has a specific meaning to the Python interpreter, and we can use a keyword in our program only for the purpose for which it has been defined. As Python is case sensitive, keywords must be written exactly as given in the table ahead. Now, as you can see, these are all the Python keywords. So like false, none, true, all these keywords have specific meaning for the Python interpreter. Finally, global, if, or, pass, race, in, else, if, elif, del, def, try, while loop, with, yield, return. Now, after understanding what are the keywords, let's understand what are identifiers. In programming languages, identifiers are names used to identify a variable, function, or other entities in a program. Now, there are certain rules for naming an identifier. Now, let us say we want to give an identifier in Python. So, the name should always begin with an uppercase or a lowercase alphabet or an underscore. This may be followed by any combination of characters like A to Z, capital A to Z, 0 to 9, or underscore. Thus, an identifier cannot start with a digit, and it can be of any length. However, it is preferred to keep it short and meaningful. So it should not be a keyword like we just read about keyword or reserved word, because Python interpreter already has some meanings associated with the keyword and reserved word. So we should not use them as part of identifier. And we should also not use any special symbols like exclamation, at the rate, or hash or dollars in identifiers. Now next are, for example, to find the average of marks obtained by the student in three subjects, we can choose the identifiers as marks 1, marks 2, marks 3, and average, rather than just giving A, B, C or A, B, C. So we should always try to give some meaningful name to the identifiers, like AVG for average, marks 1, marks 2, marks 3 divided by 3. Similarly, to calculate the area of a rectangle, we can use identifier names such as area, length, breadth, instead of single alphabets as identifiers for clarity and more readability, like area is equal to length into breadth. So here we have given meaningful names like area, length, and breadth, but avoid using. Now, as we just learned that in Python, identifiers are the names you give to variables, functions, classes, and more. But not all the names are allowed. Let's look at some examples that are not valid identifiers in Python. So first we have to name is equal to John. Now, This is invalid because identifiers cannot start with a number. Variable names must always begin with a letter or an underscore. Next, we have def is equal to 10. This one is also incorrect because def is a keyword in Python. It is used to define functions. You cannot use keywords as variable names. And finally, we have first hyphen name is equal to Amy. This is also not allowed because hyphens are not valid in identifiers. Python will think you're trying to subtract. Instead of first hyphen name, you could have used first underscore name or first name together, both of which are valid. So remember, identifiers cannot start with numbers, cannot use keywords, and cannot contain special characters like hyphens. So next, let's talk about something very simple but super important, that is literals in Python. Literals are the raw data values that are written directly into your program. They are the actual fixed values that Python immediately understands. Think of literals as the real data, like numbers, text, or even true and false, that your code uses and manipulates. There are different types of literals in Python, including string literals like hello or Python, numeric literals like 10 or 3.14, Boolean literals like true or false, and special literals like none, and literal collections like lists, tuples, dictionaries, and sets. Now that we know what literals are, let's look at some real examples. The first one being, let's see, we have a variable name is equal to Alice. This is a string literal because we are storing a piece of text. Next we have age is equal to 25. This one's a numeric literal, specifically an integer. Is underscore student is equal to true. His true is a Boolean literal used to represent true or false values in logic. Then we have grades is equal to 90, 85, 78 in the form of a list. This is a list literal, which is a type of collection used to store multiple values in one variable. Then info is equal to none. And finally, this is a special literal called none literal, used to show that a variable has no value yet. Each of these is a literal because it directly gives Python a value it can understand and work with. Now let's move on to another important concept in Python, also known as operators. Imagine you're shopping online. You add items to your cart. So that's like an addition to your cart. You check if you have enough money, that's a comparison. And you decide whether to buy it based on whether it's on sale or over budget. That's logical thinking. So in Python, we use operators to do all of these actions, from simple maths to making decisions in the code. And this sets the stage for different types of operators in Python. So an operator is used to perform specific mathematical or logical operations on the values. The values that the operators work on are called operands. Now let's take an example. In the expression 10 plus num, the value 10 and the variable num are operands, and the plus sign is an operator. Python supports several kinds of operators whose categorization is briefly explained. Now these are all the various type of operators that we'll be studying, like arithmetic operators, relational, assignment, logical, identity operators, and the membership operators. Now that we know the different types of operators, here is a list of all the operators like arithmetic, relational, assignment, logical, bitwise, identity operators, and membership operators. Each type of operator plays a key role in writing effective and logical Python programs. Now let's learn about punctuators. Punctuators are also called separators And these are the special symbols used to organize and structure your Python code. Unlike variables or values, punctuators they don't hold any data. Instead, they tell Python how to read and interpret the code. They help in organizing the structure, controlling the flow of the program, and clearly marking the start and end of blocks or expressions. Some common examples of Python punctuators are square brackets, curly braces, parentheses, and at the rate symbol, as well as operators like equal to, plus is equal to, multiply equal to, floor division equal to, among others. Even though they seem small, punctuators play a big role in keeping your code clean, readable, and correct. All right, my friends. Awesome job so far. You've built a strong foundation by learning about identifiers, literals, operators, punctuators, and tokens. But this is just the beginning. In our next session, we'll dive into the world of variables and data types, the tools that make your programs dynamic and powerful. So stay tuned and get ready for more Python magic.